Hi everybody. In this section we're looking at triangle congruence using ASA, AAS, and HL. So let's take a look at the angle side angle congruence postulate. If two angles in the included side in one triangle are congruent to two angles in the included side in another triangle, then the triangles are congruent. So you can see the two triangles to the right here. I've got two congruent angles and the included side, which is the side that both the angles share. So I can say triangle CAB is congruent to triangle ZXY. Example 1. What information would you need to prove that these two triangles are congruent using the ASA postulate? So we need the included side here between these two angles. And in part A, segment AB and segment UT are not the included side, so it can't be that one. Part B, AC and segment UV are the included side, so that's going to be our answer actually for the example. C doesn't work because again it's BC and TV are not the included side. And D is not even a side. There are two angles, angle B and angle T, so that doesn't work. Okay, example 2, we're looking at a proof. I have these two overlapping triangles here, and I'm given that angle C is congruent to angle E, and segment AC is congruent to AE, and I want to prove these two triangles are congruent, ACF and triangle AEB. So I can write the given statement, and I'm going to redraw these two triangles so I can better see what I know, what I need to find. So here's the first triangle in gray, and the second triangle here's in blue. So I'm going to rewrite what I know. I know angle C is congruent to angle E, and side AC is congruent to side AE. And look, they both share angle A, these two triangles. So I can use the reflexive property of congruence to write that statement. And now look, I've got angle, side, angle. So I can say triangle ACF is congruent to triangle AEB because of the angle, side, angle congruence postulate. And that's it. Tough part here is redrawing the triangle so you can see it. Angle, angle, side, congruence theorem. If two angles in the non-included side in one triangle are congruent to two corresponding angles and a non-included side in another triangle, then the triangles are congruent. So that's AAS. So how do you tell the difference between ASA and AAS? In the left we have ASA. You can see that the side is included. And when we have AAS on the right, you can see the side is not included. It's non-included side. Example 3. What information do you need to prove that these two triangles are congruent using ASA? So we need for A, we need to know another angle here. So we need to know angle F is congruent to angle Q. For part B, AAS, we need another angle. So we need angle G this time congruent to angle P. SAS, we need another side where the angle given is included. So we need to know segment EG is congruent to segment RP in this case. Example 4, can you prove that the following triangles are congruent, why or why not? Okay, so look, we've got two congruent angles and a congruent side. The problem here is that the congruent angles are not corresponding. They're in a different order. So no, although the angles are congruent, they do not correspond, and therefore we can't prove that these triangles are congruent. All right, another proof here for example 5. We know that segment BD is an angle bisector of angle CDA, and angle C is congruent to angle A. And we want to prove that triangle CBD is congruent to triangle ABD. So let me fix this as triangle ABD in the proof here. Okay, so let's write the given statement here. Segment BD is an angle bisector of angle CDA, and angle C is congruent to angle A. Given. So let's update our drawing here. Angle C is congruent to angle A. So in the second step, we can say something about what this angle bisector gives us. It gives us angle CDB is congruent to angle ADB, because that's the definition of an angle bisector. So let's update the drawing. Angle CDB is congruent to angle ADB. All right, statement 3. So we've got two angles here. We've got angle, angle. Now I can say that segment DB is congruent to segment DB. That's the reflexive property of congruence. And now I've got angle, angle, side, angle, angle, side. So now I can prove triangle CBD is congruent to triangle ABD because of the angle, angle, side congruence theorem. All right. So let's take a look at the next part. Any day now. Moving on. There we go. Let's take a look at the HL congruence theorem. This theorem states, if the hypotenuse and a leg are congruent to the hypotenuse and leg in another triangle, then the two triangles are congruent. So in order to have a hypotenuse, you need to have a right angle. A hypotenuse is the side opposite the right angle in the triangle. And the leg is always next to the right angle. So that's it. Triangle CAB is congruent to triangle ZXY, in this case because of the HL congruence theorem. So let's look at example 6. What information would you need to prove that these two triangles are congruent using the HL theorem, part A? Okay, so take a look at these two triangles. We know that we've got two right angles, and we know the leg, in this case CB and L, these two legs are congruent. So what do we need? We need to know that the hypotenuse for both of these are congruent also. It's the side across the 90. So how do we label that? So that would be segment CA and segment NM in this case. So let's write that. Segment CA must be congruent to NM. And remember, these two sides here are the hypotenuse of the triangles. Okay, so for the SAS theorem to work, I need two more congruent legs here, sides, to give me SAS. So I already have one side and an angle, and I need another pair. Segment BA must be congruent to segment LM. All right, so let's take a look at AAA and SSA. So these are not congruent postulates. And you can see if we know that three angles of one triangle are congruent to three angles of another triangle, that doesn't necessarily mean that they are congruent. It means that the triangles are similar. which means that they could be different sizes, even though that they're going to be the same shape. So that's what we get for
with side-side
angle
relationships, we could produce two possible triangles here. Like you can see, the red one here, we've got a 45 degree, and then the next two sides are congruent with the blue triangle. However, look, there's two different triangles. We don't know that angle and that second side. We could potentially produce two different triangles. This, as you can see, this little dashed line here that I've got could swing and make either the obtuse or acute triangle that we have here. All right, so that's it for this section on triangle congruence. Hope it makes sense. See ya.